Hi everyone, so we're going to be continuing with Unit 3. This is lesson 3.3. So today we're going to be just reviewing how we can graph given an equation in standard form for a quadratic. So to review, I've written out the 5 steps that we're going to be looking at. We're going to first factor the equation. Then when it's in factored form, we'll set the two brackets equal to 0 and we'll solve. This will be finding the zeros, which is step 2. Then step 3, we'll take those zeros, we'll add them together and divide by 2 in order to find the axis of symmetry, which is the x value of our vertex. Then we're going to sub in that equation the x value that we solve for to determine the y value, which will be our max and min. And then we'll just use the y-intercept from the standard form equation. So let's just get started here with the equation x squared plus 7x plus 10, which is given to me at the beginning. The first thing that we're going to do is take this equation and we'll try to use our different forms of factoring, which we did in Unit 2. So I'm looking at this x squared plus 7x plus 10. There's a 1 in the front. So I know that there is no greatest common factor related to the coefficients because 1 won't change anything. I've got 2 x's, 1 x, and no x with the 10, so I can't take out any x's. So because there's 1, 2, 3 terms, this is just a simple trinomial that I'm going to be using sum and product to solve for. So my sum is positive 7. My product is 10, positive 10. I'm going to look at two numbers that will multiply to give me 10, add together to give me 7, and that's of course 5 and 2. And because it's simple, so step number 1 is going to be to factor. All I have to do is write out my two brackets, x plus 5, x plus 2. Now that I'm done step number 1, which is factoring, I'm going to set these factors equal to 0, so that's step number 2. So solving for the zeros, x plus 5 equals 0, x plus 2 equals 0, x is equal to negative 5, and x is equal to negative 2. So now that I know my two x-intercepts, I'm going to take those two x-intercepts and add them together to find the midpoint, which is my equation of the axis of symmetry. So r plus s, negative 5 plus negative 2, that's negative 7 divided by 2, which is negative 3.5. Now that I found the x value, I'm going to take that, put that into my original equation, which is given to me at the beginning. I'm not going to put it into my factored equation in case I made a mistake. So then I'll replace the x's with negative 3.5. So negative 3.5. Remember to use brackets in your calculator every time that you're putting in a power of 2 or any sort of square, so that your calculator can take the negative sign with the number. So be careful, use your brackets or else you will get the wrong answer in your calculator. Type all that into your calculator and press equal. And you should end up with negative 2.25. So we're not dealing with any nice numbers here. That's okay. And then step number 5 is just to look back at our equation. So we're going to go right back to our equation. This x squared plus 7x plus 10. And our y-intercept is of course when x is equal to 0. So my y-intercept, if this is 0 and 0, it cancels out. And we're left with 10 for our y-intercept. So then we can come down. We'll write down that our y-intercept is 10. So we'll just draw a grid and then we'll begin to plot our important points, which include our x-intercepts, our vertex, and our y-intercept. So one of our x-intercepts is at negative 2. Our other x-intercept is at negative 5. We'll put 2 points to indicate that these are our x-intercepts. Our vertex is at negative 3.5 for x and negative 2.25. So this is 2, negative 2, and a little bit lower than negative 2.25. So we're right in the middle between negative 5 and negative 2, and just below negative 2 for our y value of our vertex. So this vertex will indicate that it's at negative 3.5, negative 2.2. Then we'll draw our parabola going up and crossing through a y-intercept of 10. And that's how we're going to be graphing our parabolas. So on this next page, I've given you this quadratic, which is currently not set to 0. So we have a little bit of an issue with it. It's x squared minus 8x plus 12 equals negative 3. So from 3.2, we know that we can't have this. We can't factor that. So what we're going to first have to do is set it equal to 0. That means I have to take this negative 3 and bring it over to be with the equation so that I'm left with a 0 on the other side of the equal sign. I'm going to collect any like terms. So now I've got x squared minus 8x plus 15. And now I want you to go through the steps that we just did in the video to this quadratic. So that's factor it, find the zeros, take those zeros, add them together, divide by 2 to find the midpoint, then use that midpoint to find the y value of your vertex, and then use the y-intercept, which we can already see is positive 15. And then I want you to go to the side over here and graph it. You can check your solution on the posted notes. Now we're going to be looking at quadratics in a different light through word problems. So this is a very common word problem with population of different places. So for this example, it says the population of an Ontario city is modeled by the function, and then I give you the quadratic, which is 0.5 t squared plus 10t plus 300, where PT is the population in thousands. This is going to be important for us. So the population's in thousands and time in years. Note that time is 0 in the year 2000. So what we're trying to say is that in the year 2000, that is the first year that they started recording populations. And then every year the population is increasing from that year. So what is the population in the year 2000? What this is asking for is your y-intercept. So if I'm looking at the quadratic, 0 for time, which is the year 2000, that's my starting point. And I'm not starting at a population of 0, because if I had 0 people, it would continue to be 0. But I'm starting at 300 people. How do I know that I'm starting at 300 people? Because that's my y-intercept. But we can show that mathematically. So what we're going to do to show that mathematically is we're going to write down our equation, and then we're going to replace our t, our time, with what the time is for the year 2000, which is 0. So let's just show that math very quickly here. Our population is equal to 0 t squared plus 10t plus 300, and we'll replace our t with the amount of time from the year 2000, the amount of time being 0, because 2000 is our starting point. How did I know it was my starting point? I got that information from my question, right? I'm not expecting you to know that from the top of your head. Okay, so 0 squared times 0.5 is 0, plus 10 times 0, which is 0, ends up being 0 plus 0 plus 300, which means that my initial value of the population is 300, which is my y-intercept, which is this graph that I was starting to draw over here. So now that I know I'm starting at 300, my population is going up. Then eventually my population will come down. Now what I need to note for my question is that the population is in thousands. So we have to convert the population which is given back into thousands. So the population in the year 2000 is actually 300,000 people. So that's my starting point. Now I'm going to look at the next question, which is asking me to find the total population in 2010. So if I go back to this graph that I've made, kind of like a sketch of what's happening here, the year 2000 is 0 years. Now, if I'm looking at the year 2010, that means that the amount of time that's passed would have to be 10 years from that year 2000. So I'm just going to do the exact same thing that I did above, but instead of replacing time with 0, I'm now going to be replacing time with not 2000, that's just 2010, that's just a year, but the amount of time that's passed, which is 10 years. So now I'm replacing t with 10. And again, when I write out these equations, I'm just going to type this into my calculator all in one shot, making sure that I'm using those brackets when I do so. Then I'm going to press equal, and it should spit out an answer of 450. Now we know that that 450 is not 450 people, but 450,000 people. So therefore, the population in 2010 was 450,000 people. Now for the last part to this question, it's asking me, when is the population expected to be 1,050,000? And it's saying to use Desmos to graph out and find the function of when that time will occur. But for us, we're going to use algebra. We're going to use the methods that I taught you earlier because we're going a little bit quicker with this unit. So I'm going to take this population and solve for the time of when that population will occur. This is asking me to find out the x-intercepts or the x values of that time. So for me, the first part that I'm going to do is take this population and reduce it by 1,000. So that's those 3 zeros there. I'm reducing the population by 1,000 because I know that my equation is in thousands. So that's step number 1. Step number 2 is to replace the value inside my equation with the new population. So my equation, just to write this down again, is population is equal to 0.5 times time to the power of 2 plus 10 multiplied by time plus 300. So I'm trying to find these t values or time. So I know that my population, or want my population to be 1,050, which is actually 1,050,000. And now I'm going to solve for time through factoring. So just like we did before, we have to take any value on the opposite side of the equal sign and bring it over to equal 0. When we do that, we're going to change the sign. So now our new equation has a negative 750 at the end. Now with this, we're going to begin factoring. So the first form of factoring that I should always try to use is called greatest common factor. I've got that 0.5 at the front, and I'm going to take that out of my whole equation. So that's my greatest common factor right now. I know that I can't take out any t value because that 750 doesn't have any. That 0.5 just goes to the front. Put your brackets, and then start reducing your equation. So 0.5 divided by 0.5 is 1. 10 divided by 0.5 is 20. Negative 750 divided by 0.5, we're going to double that. So that's negative 1,500, 1,500. Oh, forgot the t with that 20. And now looking at this, so I've got a trinomial. So I'm going to be using sum and product. And thank goodness it's a simple trinomial because these are quite big numbers. So I've got 1,500 and positive 20. Sorry, that's negative 1,500. And now the two numbers that I'm going to try to figure out for the product, well, I got to think. They're going to be 20 apart. There's going to be a difference of 20. So my two numbers could be, and I'm going to try out, 50 multiplied by 30. 50 times 30 is 1,500. And 50 and 30 are 20 apart. So now to figure out my signs, I'm going to take the sign of the sum, like we've always been doing, putting it with the bigger number, and then that means that the 30 is a negative. 50 minus 30 is positive 20, and 50 times negative 30 is negative 1,500. So that works out nicely. That 0.5 doesn't disappear, doesn't go anywhere. We set up our two brackets. T, positive 50, and negative 30. Now we're almost done. Our last step, now that we've factored our equation, is to find the zeros, or find the t values. So we'll do t plus 50 equals 0, t minus 30 equals 0. We're going to take this positive 50 and bring it over, and it becomes negative 50. We'll take that negative 30 and bring it over, and it becomes positive 30. Now this is relating back to that other question that we did in lesson 2, where we have to choose a realistic time. We can't have negative 50 for a time. That doesn't exist. You'd be a time traveler. So all we can have is t equals 30. So 30 years from the starting point, that's when you'll have a population of 1,050,000. So if I go back to that little graph that I gave myself, so 30 years, if that's 10 years, 30 years after, I would get a population of 1,050,000. So what's 30 years? If it's asking me when, you can't just say in 30 years. You have to give a specific date. So my starting point, to go back to the question, my starting point, year 0, is in the year 2000. So the year, 30 years plus 2000, is the year 2030. So in the year 2030, the population will be 1,050,000.